Hi everyone, I am Dr. Archana Bhatt, Assistant Professor of Mathematics, Department of Freshman Engineering, St. Martin's Engineering College, Hyderabad. Today I am presenting on the topic probability distribution function. So first we will see the outline of my topic. First I am giving the definition of random variable, types of random variable, continuous probability distributions and discrete probability distributions. So, what is a random variable? First, we will see. If I am tossing two coins simultaneously, what my sample space contains? If I toss two coins simultaneously, I may get both head or one head, one tail, and first one tail, second one head, or else both tails. So, random variable is a function which assigns a value for each of my sample space. So my sample space contains head, head tail and both tail. So if I choose a random variable x equal to getting a head, then my sample space for x equal to, it is for getting two head, it is a number, say suppose 2 head both, two heads. So the variable gives the value 2 and head tail the number 1 x equal to 1 and tail head x equal to again number 1 and both tail the number x equal to 0. So my sample space for each outcomes of the experiment in the sample space, it gives the value 0, 1, 2 respectively for the random variable x. Then what are the types of random variables? Discrete random variable and continuous random variable. Types of random variables. Discrete random variable means if my sample space contains discrete outcomes, then I can count that by finite number of values or else countably infinite number values. If x takes the value finite numbers or countably infinite number, then my random variable is called discrete random variable. Suppose my sample contains in the interval, suppose for example height of a person or weight of a person, then it is in some interval of time, then such a random variable we will call continuous random variable. Suppose if I am climbing the steps of the Charminar, then it is finite numbers. So that is example of random variable which is discrete random variable. Then time we stay on Charminar, that is a time interval. So that is the continuous random variable. Then what is probability distribution? Probability distribution is again a function which assigns the probability values for each outcome of the experiment. Suppose my experiment is tossing two coins simultaneously. My sample space contains 4 outcomes. So, what is probability? Probability is getting the outcome divided by total number of outcomes. So, getting heads both, that is 1 by 4 because we are having only both the heads as only one outcome. Suppose if I want to get only one head, then my probability function gives me the probability of x equal to 1, that x is a random variable getting one head, is assigning a probability value 1 by 2 because I have two chance of outcome, that is either first one head, second one tail, or first one tail, second one head, getting one head at a time, having the probability 1 by 2. So these type outcomes, discrete random variables gives us discrete probability distribution. So if we want to see what is the probability, always greater than 0. Why? Probability is the number of outcomes of getting our event divided by total number of outcomes of the event. So probability of x is greater than 0. If you take the summation of all probability values, that is gives us a maximum amount of 1. If we see the mean and variance, mean is the average. So mean is the average which gives for discrete probability distribution, mean mu is given by expectation of x. In case of discrete random variables and discrete probability distribution, we have the mean expectation of x equal to x into probability of x, and variance of x equal to expectation of x minus mu whole square. That is nothing but expectation of x minus mu whole square is turning to expectation of x square minus expectation of x whole square. Let us see how we can derive that expectation of x minus mu whole square. Suppose now I want to calculate variance. Variance equal to, symbol notation is sigma square. That is variance sigma square equal to expectation of x minus mu whole square. The notation for mu is again a average. Mu equal to expectation of x. So if I expand x minus mu whole square, I am going to get expectation of x square plus mu square minus 2 times x into mu. If I substitute in place of mu, if I substitute expectation of x, I am getting expectation of x square plus expectation of x whole square minus 2 into x into expectation of x. So, if I take the expectation inside and using the properties of the expectation, I will get expectation of x square plus expectation of x square. Expectation of x is already a constant. So, again its expectation means again its average is a constant. So, that is expectation of x whole square minus 2 times expectation of x into expectation of x. So, here again expectation of x into expectation of x, that is turning to expectation of x square plus expectation of x whole square minus 2 times expectation of x whole square. So, my total value of variance will be expectation of x square minus expectation of x whole square. So, instead of computing expectation of x minus mu whole square, easily we can compute expectation of x squares, and to get the variance we can do that sigma square variance equal to expectation of x square minus expectation of x whole square. So, coming to the our slide, if we see the expectation and variance of the discrete probability distribution, the expectation mu is equal to summation x into p of x. Variance sigma square equal to expectation of x minus mu whole square, that is nothing but summation of x minus mu whole square into p of x. So, we already derived sigma square equal to expectation of x square minus expectation of x whole square. So, what are discrete probability distribution? Let us see. Suppose if I am having only two outcomes, yes or no responses, then such a distribution we can call as Bernoulli distribution. If yes or no responses are repeating n times, then such a distribution we will call as binomial distribution. We will see binomial distribution in detail. Negative binomial. If number of trials in the kth event will going to give me the negative binomial distribution. So, Poisson distribution gives me if there are infinite discrete number of values, then I am going to get Poisson distribution. Geometrical distribution. Suppose if I am doing some experiment, then number of trials until my first success will tends to the geometric distribution, multinomial distribution. Multiple possible outcomes of the distribution will leads to a discrete probability distribution called multinomial distribution. Now we will see binomial distribution. In binomial distribution, we are having a random variable x, which is a discrete random variable, and we are going to take n number of trials. Each trials as having equal number of possible outcomes. Suppose probability of success equal to p, then probability of failure will be 1 minus p, that will be denoted by q. So the each trials are independent on each other. So previous what is the experiment I have done, that will not affect my next experiment. That is, trials are linearly independent. If x is the number of successes, then we can take the value of x up to n, 0, 1, 2, 3 up to n. Suppose if I am tossing 3 coins simultaneously, then I will get totally 8 possible outcomes in the my sample space. Probability of getting head equal to 0.5 and probability of getting tail equal to 0.5. So probability of getting tail I am denoting by q, that is probability of a failure. So if a coin is flipped 3 times, then what are the probabilities, outcomes in the sample space and respective probabilities, and combined probability of those will be summarized in this table. So what is the probability mass function of the binomial distribution? If I am having the n number of trials and each trial will gives me yes or no response, that is true or false also you can say, then its probability mass function is given by n chosen x, ncx, p power x, q power n minus x, where p is the probability of getting success, q is the probability of getting failure. So next, what is the mean and variance of this binomial distribution? Mean and variance are the main constants which we are going to calculate, and mean of the binomial distribution is given by np and variance is given by npq. How they are giving? So if you calculate mean, mu equal to expectation of x. Expectation of x is nothing but, in case of a discrete probability distribution, we have expectation of x equal to summation of x px. So if I substitute summation k ncx p power k 1 minus p power n minus k, then I can adjust the one variable, I can take np out, then remaining summation if I adjust, that is going to be p plus q whole power n minus r. So np is as a constant and p plus q is giving me the constant value 1. So the total mean value is np. If I want to calculate similarly sigma square variance, already we have derived that variance is sigma square equal to expectation of x square minus expectation of x whole square. So expectation of x square is nothing but np into np minus p plus 1. So if I substitute in the formula of sigma square equal to expectation of x whole square, expectation of x square minus expectation of x whole square, I am going to get variance sigma square equal to npq. That is what the variance and mean of the binomial distribution. Suppose if I am having the binomial distribution example, there are the given that 40% of the class is female, 40% of the students are female students. So what I have to take for probability p of getting the female student is 0.40, because probability always lies between 0 and 1. what is the probability that 6 of first 10 students walking will be female? So by the formula P of x equal to NCX P power x Q power n minus x. P I can take 0.4, Q equal to 1 minus P, that is nothing but 0.6. What I have to calculate is probability that 6 of the first 10 students. So n I have to choose 10 and x I have to choose 6. If I substitute in the formula, total answer of the probability of x I am getting 0.115. So in this pictorial diagram, we can see that when the binomial distribution can tends to a normal distribution. Suppose I am having the binomial distribution with the less number of trials, then this is the rectangular representation, rectangular bars which gives me each probability. Suppose if n is 5, for different probability p values, I am having the shape of the rectangular bars. So as n goes up, then the whole probability is going to be in the symmetric shape. If p value is going to be very small and going to be very large, we can get the probability distribution of the binomial distribution will goes to normal distribution, which is a continuous probability distribution. Next one is one more important, very important distribution, which is a discrete distribution called Poisson distribution. In Poisson distribution, the main property is if n is very large and p is very small, we are going again from using the binomial distribution, we can get the Poisson distribution. If suppose there are outcomes such that waiting time like that, then we can take Poisson distribution examples. So Poisson distribution is a very important type of discrete probability distribution in which x is taking the values infinite number, x equal to 0, 1, 2, 3, so on up to infinity. In case of binomial distribution, we are going to take only x equal to 0, 1, 2 up to n finite number. This is Poisson distribution is countably infinite. We can count, but it is infinite. So probability mass function of this Poisson distribution is given by P of x equal to e power minus lambda, lambda power x divided by x factorial, where x is taking the value 0, 1, 2 up to infinity, and lambda is the constant called mean, always that lambda value is greater than 0, and e is the Euler number which is having the value 2.718. We can see the mean and variance of this Poisson distribution is lambda. If we substitute in expectation of x equal to x into p of x. If we substitute expectation of x equal to summation x e power minus lambda, lambda power x whole divided by x factorial. You can adjust the power of lambda power x so that the expectation will be lambda. Similarly, if you calculate expectation of x square minus x, we are going to get lambda square, so that variance of x is lambda square minus lambda plus lambda, so that we are going to get a variance of x is lambda. So the next type of distribution, if we see the example of Poisson distribution, if there is a one throat which gives average of 3 striped throat per 100 yards. So what is the probability of getting 5 out of 100 next yards? So if we substitute lambda equal to 5, then we will get the probability of getting x equal to 5 is 0.111008. Next, we will see some continuous probability distribution. If continuous probability distribution, the values of the random variable x takes some interval. So if you want to calculate the probability, you have to calculate in some interval. Probability of getting x between the interval a and b is given by integration a to b f of x dx, where f of x is called probability density function for continuous probability distribution. Suppose, similar to the probability of discrete probability distributions, we are going to see that f of x is greater than or equal to 0, and if you integrate from minus infinity to plus infinity, total probability is going to be 1. So, probability density function of the f of x curve is given here, and also area under the curve gives you the total probability. If you see the graphical representation of this continuous probability distributions, if you want to calculate the probability of from A to B, we have to take the area from A to B. Then that will gives you the probability over the interval A and B. So if we want to calculate the mean mu, that is nothing but expectation of x, then expectation of x is x integration minus infinity to x into f of x dx, and similarly variance of x is nothing but expectation of x minus mu whole square. Similarly, here also for variance we can get expectation of x minus mu whole square equal to expectation of x square minus expectation of x whole square. So one of the very important normal distribution is we are having the probability function 1 by root 2 sigma pi e power minus x minus mu whole square by 2 sigma square, with the parameters sigma, and sigma is the variance and mu is the average, that is nothing but expectation. This any normal distribution we can convert to standard normal distribution by taking its values to variance equal to 1 and average mean mu equal to 0. If we want to see some of the other continuous probability distribution, we can see in this video the some useful continuous probability distributions are. First one is first one we can see as some probability discrete functions which are Bernoulli distributions. Bernoulli distribution with a parameter 0 and 1, probability mass function is rho power x 1 minus rho power 1 minus x. When rho values are changing, we can observe the bars, how the probability values are changing. Next one is binomial distribution. X belongs to n with the parameters rho and n. N takes the value 0, 1 to up to n. NCX p raised to x 1 minus p raised to n minus x is the probability mass function, and expectation of x equal to np. With the parameters n and p, we can observe the difference in changing of all the values. We can see the curve. Next one is Poisson distribution. If we observe the Poisson distribution with the mean lambda belongs to r plus a lambda greater than 0, and probability mass function is given by e raised to minus lambda power x by x factorial with expectation of x equal to lambda, we can see the values of each of the lambda values varies, how the curve is changing. Then next distribution is normal distribution. Also this distribution is called Gaussian distribution. For x belongs to r, in this normal distribution we are having the two parameters mu and sigma square. Sigma square is the variance and mu is the average or expectation of x. With the probability density function 1 by 2 sigma square pi expectation of x minus mu whole square divided by 2 sigma square. Expectation of x is mu. As mu and sigma values are changing, how the probability curve is changing we can observe. If mu equal to 0 and sigma equal to 1, that leads to the standard normal distribution curve, which gives me to find various values of the distribution. Gamma distribution for x equal to r plus, we have the parameter alpha and beta with the probability density function beta power alpha gamma alpha x power alpha minus 1 e power minus beta x. We can have the expectation alpha by beta. If alpha and beta values, that are the parameters, changes, we can observe various values of the curve, how it is varying as alpha and beta values are varying. These gamma distribution mainly depending on the gamma function. Also, next one is a beta function. Beta function mainly depending on the beta function with a parameter alpha and beta, which are positive real values, and probability density function f of x alpha beta is given by x power alpha minus 1, 1 minus alpha power beta minus 1 divided by beta of alpha beta. Expectation of x is alpha by alpha plus beta. Also, we have seen how the values are varying in that. If I want to see the some problems on normal distribution, which is basically a very important, we can observe that when the values of the normal distribution is given, we can see that we can convert that into standard normal variable, and then we can find the probability value. One example we will see. So in this example we are considering the normal distribution. In this normal distribution, a toy car goes an average of 3000 yards between the recharge station with the standard deviation is given 50 yards with the parameters mu equal to 3000 and sigma square equal to 50. We can choose then what is the probability that a car will go more than 3100 yards without recharging. So if here our aim is to calculate probability of x greater than 3100. So probability of z we are converting, the normal distribution we are converting to standard normal variation. So probability of z greater than 3100 minus 3000 divided by 50. 50 is the standard deviation sigma. So probability of z will be greater than 2.0, that is 1 minus, if I want to calculate probability of z greater than 2, so I want to take only this area covered. So total probability we know that it is 1. So 1 minus probability of z less than 2, then our task will be done with this. If I want to calculate, then my total probability will comes to 0.0228. Now we will see how to calculate the area under the curve for normal distribution. So in this, if I am having probability to calculate under the given normal curve, then suppose so this is the probability distribution of it is a symmetric bell-shaped curve. If I want to convert normal distribution to any standard normal distribution, then my variance will be 1 and the mean mu equal to 0. So I am taking the bell-shaped curve. So I want to calculate the area between these two intervals, A and B. So my expectation is to calculate the probability between these two A and B points. So what I have to do? I know that the total probability of x is summation of px equal to 1. So in this continuous case, I am having integration of px equal to 1. So I want to calculate the area between A and B. So to calculate the area between A and B, I will take probability of A less than or equal to x less than or equal to b. From the probability table, I can check that 1 minus probability of a less than x, I can take and minus 1 minus probability of plus and minus probability of x less than b. If I do this work, then my whole job is done. That gives me the total probability under this area. So with this, we can see that the curve, the probability of the normal distribution will giving me the area of 0.68 covered with mu minus sigma and mu plus sigma limits. So if I am taking 1 sigma limit, then it is 68% area is covered, 2 sigma limits 96% area, 3 sigma limit 99% area is covered with this standard normal deviation. So with this, I would like to thank all of you.